Let's talk about something called indirect measurement. We're talking about geometry and congruence and similarity, and now we're going to talk about how to use that to help us solve problems. Before we do that, though, I want to show you a picture of the summit, the peak of a mountain called Burke Kang, or Burke Kong, I'm not sure how you pronounce that. This is a tall mountain in Nepal, and it's actually named after this guy, Bill Burke, who actually lives only about 10 minutes away from Talbot Middle School. And he is the oldest person to have ever climbed Mount Everest. He climbed Mount Everest at the age of 73 in 2014. And so the people of Nepal named one of the peaks after him, which is kind of a cool thing to have a mountain named after you. Now, you can read more about that at this link right here if you want to, but what I want you to know about the summit of this mountain is that it reaches a height of 6,942 meters, which is 22,775 feet. But I also want you to know that there's something interesting about this mountain peak. Nobody has ever climbed it. Nobody has ever climbed it. So, the question is, how do we know that that's how tall it is if nobody has actually ever been up there? In fact, how do we know how tall any mountain is? You can't measure a mountain with like a measuring tape or a ruler, right? How do we know the heights of mountains? Well, the answer is what we call indirect measurement. When you can't measure something directly with a ruler or a yardstick or a measuring tape, you have to find other methods. And math gives us indirect measurement. So indirect measurement is a technique that uses properties of similar polygons, similar, we've seen that word, to find distances or lengths that are difficult to measure directly. In other words, what we can do is we can find the heights of mountains that are really tall, or we can find the distance across a river without having to swim across it, or we can even find the diameter of the moon, which we definitely can't measure with a ruler or a yardstick, using indirect measurement instead of direct measurement. So how does this work? The way it works is by using similar triangles, or some other kind of similar shape, but it's usually triangles. So here's how it would look with the mountain. If you want to know how tall the mountain is, we could make a triangle to represent the mountain. Now, we can't measure all the parts of that triangle, but we could make a similar triangle that is a size that's measurable by us. And if we know the size of the smaller triangle, then we can use the properties of similar triangles to help us understand the measurements of the larger triangle. Indirect measurement. So here's an example of what that might actually look like. A 5-foot person is standing near a tree, and the person casts a shadow that's 12 feet long. The tree also casts a shadow that's 42 feet long. What's the height of the tree? Well, step one, we've got to sketch this thing out so that we can visualize it. So here's a quick sketch. There's a tree, we don't know how tall it is, and its shadow is 42 feet long. There's a person, we know their height, they're 5 feet tall, and we can measure their shadow is 12 feet long. So we can use this to help us discover the height of the tree. And we don't have to actually directly measure the height of the tree, we can use proportions, because we know similar triangles have proportional relationships. So I'm going to say that x over 5 equals 42 over 12, and then step 3 is, well, we've got to do some cross multiplication and solve this thing. So we're going to have 12 times x equals 5 times 42, and then we're going to multiply 5 times 42 and divide it by 12, and eventually use our calculator and get that x equals 17.5. So what is the height of the tree? The tree is 17.5 feet tall. And we didn't need to measure the tree, we just measured a couple shadows and the height of a person. This is what we call indirect measurement. And when you use shadows to do it, it's what we call a special kind of indirect measurement called shadow reckoning, which is kind of a cool phrase. It kind of like, anyways, the first person that we know of in human history who performed shadow reckoning was an old dead Greek guy named Thales. And Thales lived about 2,600 years ago. So a long, long, long time ago, Thales really impressed people by finding the height of one of the great pyramids of Egypt. But of course, he didn't measure it directly. He just used shadow reckoning to find the height of the pyramid. And of course, everybody was super impressed. And they thought, wow, Thales, this is amazing. You're so intelligent. Plus, look at you. Your eyes have no pupils or retinas. That's, well, actually, that's kind of creepy. But we like you anyways because you're so smart. Anyways, shadow reckoning. So if you ever start like a band, like a emo core band, and you're looking for a good name, maybe you could call yourselves Shadow Reckoning. Anyways, how about you try to do a little shadow reckoning? How about you try to do a little bit of indirect measurement here using similar triangles? So read this problem, maybe pause the video, and then see if you can do step 1, draw it out. Do step 2, make some proportions, and then do step 3, solve the proportions to come to an answer. In fact, okay, I'll do the drawing for you. Hopefully you can see how that drawing relates to that word problem. And what the heck, I'll just go ahead and make a proportion for you. X over 6 equals 9 over 4. Make sure you can see the connection between that drawing and those proportions. If not, write down a question or put a star or something so that we can talk about this tomorrow. Then, of course, we're going to cross multiply 4 times x equals 6 times 9. And if you did it all correctly, why not? I'll just go ahead and give you the answer. It's 13.5 feet. All right, if you can do this problem, you're doing indirect measurement. And it's really just an extension of what we learned about similar triangles or similar figures. I think this is pretty cool, and I think it makes a lot of sense, and hopefully you're taking good notes, and we can do some more indirect measurement in class tomorrow. All right, see you later.